Let's start with Cloud SQL. Cloud SQL, which is a fully managed relational database service for MySQL, Postgres, and SQL Server. These are the three databases which is supported. Relational database, by definition, is any database which provides ACID support and also provides referential integrity. So a question comes, why not have these MySQL, Postgres, and SQL Server on a VM rather than having a Cloud SQL? So when it comes to relational databases, apart from actually working on the database, there's always an administrative overhead to maintain these databases. These overheads are normally backups, high availability and failover. Network connectivity is a big challenge. Export and import of data is, again, you have to use some sort of data engineering to be able to do that. Maintenance and updates, every time there has to be a downtime of the database to apply a patch or apply or upgrade the version. Monitoring, you have to look at external features to external features and create dashboards to have a proper monitoring on the database, and also the logging. Now, each one of the administrative overhead of these, in fact, any database, create sort of dependency on certain skills, dependency on certain resources. What Cloud SQL does is Cloud SQL abstracts you away from all of these administrative overhead. So in a clear sense, it's basically, it gives you a flyer to just bring in your data and use the database. So it provides you the database instance and everything on top of that, which is part of the managed services offering. So monitoring, logging, and all of these services, it's part of the offering. Now, if we look at different features of it, the one of the most important feature is the compatibility. So it is compatible with standard MySQL, Postgres, and Microsoft SQL Server. So when you are migrating your applications, you are sure about the application compatibility. The second bit is that the migration is very easy. Database migration services makes it very easy to migrate your databases from on-premises or even from compute engine to Cloud SQL with minimum downtime. It gives you secure access and connectivity because Cloud SQL data is encrypted when it's on Google's internal network and when it's stored in database tables. Next one is it's in terms of the high availability and failover, it has a built-in high availability. So you can replicate instances to another zone or region with just a click of a button. It is highly scalable. You can easily scale up as your data grows. Then it also gives you automatic storage increases, because typically, with the databases, the number of cores, memory, and the storage, that's always a challenge when data grows. But Cloud SQL takes care of all of this automatically. It also has easy integration to all of the Google Cloud services, like anytime you need to access database from your application. So in Google's case, through App Engine, Compute Engine, or Google Kubernetes Engine, it's very easy because it's within Google ecosystem and there's an inbuilt integration methods. It provides you automatic backups. So you can automate daily backups and all sorts of logging. It also gives you point in time recovery, which is, you can restore instance to its state at any earlier point of time. and it gives you standard APIs. So basically not just about the data, how you organize your model, how do you store the data, every administrative overhead, every integration challenge is taken care by, and it's part of the offering. So it makes it a very compelling reason to use Cloud SQL rather than using MySQL, Postgres, SQL Server on a VM. Now, how do you access this database? So one of the very important way of accessing this data, the Cloud SQL, is using Cloud SQL auth proxy. So the Cloud SQL auth proxy works by having a local client running in the local environment. So if you look at this diagram, this is the client machine and this is the Cloud SQL. You have a proxy client running on your laptop, which basically connects to the proxy server, which connects to the database. And so one of the main reason why this is important and this is recommended is because of the secure connectivity. Every time you're on a cloud, security is always definitely a challenge, and especially if you're holding the data. So the Cloud SQL auth proxy automatically encrypts data traffic to and fro from the database using TLS version 1.2 with a 128-bit AES encryption. SSL certificates are used to verify client and server identities. And also it basically makes the connection management very easy because you don't need to have public IP addresses, because typically if you need to access it outside Google Cloud Platform, you'll have a public IP which introduces risk. So with this, you don't need public IP addresses to access Cloud SQL database. Now, apart from these, there are standard ways. G-Cloud, with anytime you're using G-Cloud SDK, there are SQL language connectors. You can also access it from Cloud Shell, which I often use to do so. And then you can use it from access it from apps scripts as well. Apart from that, it gives you a very familiar way of connecting to Cloud SQL through third-party tools like MySQL Workbench, Toad, SQL, or in case of SQL Server with PHP admin. With this, let's quickly look at CloudSpanner. Now, everything that you looked at Cloud SQL from a relational database point of view, add the horizontal scaling. So CloudSpanner, again, fully managed relational database with unlimited scale, horizontal scale across regions. When it comes to scaling, vertical scaling is an easy bit. So vertical scaling means basically, within the instance, you can increase the capacity. But horizontal scaling means is basically to be able to scale it to different zone, different region, or in fact all across the globe. So horizontal scale is always difficult with any relational systems or any storage systems. That's what CloudSpanner provides you. It provides you relational semantics, which is you have the complete support for schemas, AC transactions, SQL, plus it provides you horizontal scaling, and that to 99.999% SLA. So it's very important to remember the difference between Cloud SQL and CloudSpanner. Relational plus horizontal is where CloudSpanner is used. Let's look at its architecture. CloudSpanner architecture is basically split between compute and storage. So in CloudSpanner, everything is replicated. So everything is replicated at least 3 times. So in this example, compute, which is the node server, each one of these nodes are replicated across 3 zones, and this is a regional instance. So node 1, node 2, node 3. Now these nodes, they only serve the read and write or commit transaction request. They do not store the data. Data is stored in the storage layer, and this storage layer is based on Colossus distributed replicated file system. Google uses Colossus file system for most of its storage, in fact across a lot of database systems as well. So within a zone, you have the compute nodes, and then you have, as part of storage, you can have multiple databases. So all the way from DB1 to DBN. Now within each one of these databases, the data is stored in different splits. So what is a split is each table in the database, in case of Spanner, is sorted by primary key, and the range of that primary key is defined by splits. So if you have, let's say 1 to 10 primary keys, so a range of 1 to 3 becomes one split, and each one of these splits are replicated 3 times. So everything in CloudSpanner is replicated across 3 zones, and the same goes for even split management. Now, what's also important is that as and when your data grows, CloudSpanner does automatic sharding or resharding of data. So if your primary keys were 1 to 10, it becomes 1 to 20. It will automatically redistribute the data across different splits. Now, at a time, so out of these 3 nodes, at a time, you will only have one leader node, and the others will be follower nodes. So for node 1, node 1, there'll be only one leader node, and one split is only assigned to one leader node. And the way this is achieved is called Paxos protocol, it's a protocol to identify the leader. And the leader is responsible for managing write transactions for that split, while the other replicas can be used for reads. And this is exactly how CloudSpanner receives that kind of scalability, because it has that leader node which is responsible for write, and all of the read ones get directed to follower nodes. So I hope this was useful. Let's look at Cloud SQL and CloudSpanner from Google Cloud Console. Cloud SQL and CloudSpanner, they both can be accessed from under database section. So here is SQL, Spanner. If you click on SQL, it basically displays you all of the instances. So in this case, I have a SQL instance, but if you click on create instance, it will give you an option whether MySQL, Postgres, or SQL Server. You can choose any. So if I go back to my instance, and if you click on this instance, now on the front page, it displays you public IP addresses, how you can connect to this instance, a lot of other information. And when you click on the instance, it has a detailed page to look at different stats, different ways to access it, different operational information, also the connection part of it, from networking point of view, whitelisting point of view, users. In this case, I only have a root user, but you can add user with different roles. Databases, there are the default databases, plus this is the database that I have created. Then again, backup and everything. And it's very easy to connect from Cloud Shell, or even from APIs. So this is the kind of command you use. Create database example, very simple. To connect, you use the SQL connect, which is a very straightforward command. And then, every time you're using a database, you use, then create table entries, insert into entries, and then select a star from this particular table. It's very intuitive. Apart from that, there are a lot of APIs. So this is a reference document from all the APIs that's available for Cloud SQL. And you can see Google lets you try out all of these APIs. So for example, how do you create a new Cloud SQL instance by using an API? And it gives you an option to try out from here. Similarly, there are how to import data, how to export data. Most of those APIs are here, which you can try out directly from this browser as well. As well as, you can use a third-party application, or in fact, the other products within Google ecosystem, they also interact with Cloud SQL using these APIs. Now let's also look at CloudSpanner from Google Console. Spanner is again under databases. So if you click on Spanner, the concept of a spanner is that you have instance, and within instance you have databases. So for this example, I've created an instance called Spanner instance. Now within the instance, you can create multiple databases. So for example, I have my sample DB and Spanner DB. Now, if you click on a database, within a database, you have multiple tables. So for this particular example, I have multiple tables. Now, Google also provides you a lot of different ways to import and export data, export options for CloudSpanner. It's tightly integrated with data flow. There are a lot of templates there. There are a lot of templates to be able to move data from cloud storage to Spanner and vice versa. The other good option is, if you can click on query, you can run directly a query against your databases tables right from here. And this UI should look very familiar. In fact, it's very similar to BigQuery as well. So in this case, I'm running this command, select a star from storage, order by score, desk, describe limit 10. If you click on this one, it will run that, and it will display the result right at the bottom. You can also look at the schema of your tables. It also does explain query for how your query ran. So this is, in fact, what are the operations that it went through. And then yes, result, which has everything. So I hope it gave you a very good understanding of Cloud SQL and CloudSpanner in terms of really understanding how important, or the different features Google has when it comes to taking care of relational needs. Always remember, Cloud SQL, fully managed service for prime databases like MySQL, Postgres, completely on the relational side, ACID compliant, referential integrity, and all of that. CloudSpanner gives you everything that Cloud SQL gives, plus horizontal scaling, because Relational databases normally don't scale horizontally. They can scale vertically, but not horizontally. CloudSpanner is the option for that. So if you need a database which needs to store relational database, but have it available all around the globe with minimal latency, CloudSpanner is the solution because it scales horizontally across the globe. I hope this was helpful. Thank you.